This week, the James Webb Space Telescope once again reminded humanity why it represents a revolutionary leap in our ability to explore the cosmos. With the release of a breathtaking new image, Webb unveiled a dazzling and richly textured portrait of a nearby stellar nursery, offering scientists and the public alike an extraordinary opportunity to peer into the very heart of star formation. More than a simple photograph, this image serves as a scientific goldmine, revealing how countless stars are born, evolve, and ultimately shape the galaxies they inhabit. At first glance, the scene feels almost surreal. Vast swaths of glowing orange and deep shadowy brown clouds stretch across the frame, creating an immersive cosmic landscape that seems to blur the boundary between art and science. The colors swirl and fold into one another like billowing smoke frozen in time, evoking a sense of motion and energy that feels unmistakably alive. Yet this striking vision is not a work of imagination. It is a remarkably detailed view of Westerland 2, a powerful and dynamic star cluster embedded within the star-forming nebula known as GUM-29. This stellar nursery lies approximately 20,000 light-years away from Earth, tucked deep within the Milky Way galaxy. Even at that staggering distance, the James Webb Space Telescope is able to resolve extraordinary detail, thanks to its unparalleled sensitivity to infrared light. By observing the universe in wavelengths invisible to the human eye, Webb can penetrate thick veils of dust that have long obscured regions like this from traditional telescopes, revealing the hidden engines of stellar creation. Westerland 2 itself is a compact but extraordinarily intense cluster. Measuring between roughly 6 and 13 light-years in diameter, it may seem modest in size when compared to the vastness of the galaxy, yet it is densely packed with stars. According to the European Space Agency, the cluster contains an estimated 3,000 stars, many of which are still in their earliest stages of life. At just around 2 million years old, Westerland 2 is a cosmic infant, but it already hosts some of the most extreme and powerful stars known in the Milky Way. Westerland 2 features rare and short-lived stars like Wolf-Rayet stars and luminous blue variables known for their extreme heat and luminosity. Their powerful radiation and stellar winds sculpt the nebula into striking shapes, transforming it from a dark cloud into a glowing masterpiece. Astronomers are familiar with this region as Hubble observed it a decade ago during its 25th anniversary, revealing its iconic structure. However, Hubble's visible light imagery couldn't penetrate the dense cosmic dust, leaving many stars hidden. The James Webb Space Telescope, equipped with advanced infrared instruments NIRCam and MIRI, captures a more detailed view of Westerland 2, revealing bright young stars that were previously invisible. This new image showcases intricate filaments and arcs formed by stellar winds. Notably, massive stars at the center act as sculptors, creating areas of star formation while casting shadows on others. The interplay of light and darkness highlights the ongoing cycle of creation within the nebula. Threaded throughout the scene are delicate wisps of blue and pink gas, adding layers of depth and complexity to the cosmic tableau. These wisps drift through the nebula like ethereal smoke, marking regions where energetic radiation excites surrounding atoms and molecules. Scattered among them are countless tiny points of light, newly formed stars just beginning to emerge from their dusty cocoons. Their faint glow represents the earliest visible stages of stellar life, moments after ignition. Closer to the foreground, larger and more mature stars dominate the scene. These stars shine with remarkable brilliance and display the distinctive 8-pointed diffraction spikes characteristic of the James Webb Space Telescope's optics. These patterns, while visually striking, are also a reminder of the precision engineering behind Webb, a machine designed to capture the faintest whispers of light from the depths of space. What this image ultimately reveals is not a static snapshot, but a moment frozen within a vast and ongoing cosmic process. Westerland 2 is a stellar nursery in the truest sense, a region where stars are continuously being born from collapsing clouds of gas and dust. As young stars ignite, they unleash radiation that heats their surroundings, altering the conditions for future star formation. In some cases, this energy triggers the collapse of nearby material, leading to the birth of new stars. In others, it disperses gas entirely, bringing star formation to an end in that region. This delicate balance between creation and destruction lies at the heart of stellar evolution. It is a process that unfolds over millions of years, shaping not only individual stars, but entire galaxies. By studying regions like Westerland 2 in such extraordinary detail, astronomers gain crucial insights into how stars form in crowded environments and how massive stars influence the fate of their neighbors. The scientific value of this image extends even further. By observing Westerland 2 across multiple infrared wavelengths, James Webb can detect the chemical fingerprints of various molecules within the nebula. Some wavelengths are particularly sensitive to emissions from polycyclic aromatic hydrocarbons, or PAHs, complex molecules made of carbon and hydrogen. These molecules glow when exposed to ultraviolet radiation from nearby stars, tracing regions of heated gas and dust. Other wavelengths reveal the presence of methane, a molecule associated with cooler environments and lower mass objects. By analyzing these signals, astronomers have identified a population of elusive brown dwarfs hidden within the cluster. Often described as failed stars, brown dwarfs occupy a unique middle ground between stars and planets. With masses ranging from about 10 to 90 times that of Jupiter, they are too small to sustain the nuclear fusion that powers true stars, yet far more massive than any planet. Some of the brown dwarfs found in Westerland 2 have masses as low as 10 times that of Jupiter. This challenges what astronomers believe is possible in such a highly active area. Their existence gives important clues about how different-sized objects form together in crowded star clusters, which questions current theories of star and planet formation. Webb's observations also help us understand the layout of stellar nurseries. The data reveals how planet-forming disks around young stars are structured, showing how material is spread out and changes under strong radiation. These discoveries help astronomers understand the early stages of forming planetary systems, including how conditions might create worlds like Earth. This new image of Westerland 2 showcases the capabilities of the James Webb Space Telescope. It combines stunning beauty with significant scientific insights, turning a distant part of space into a vivid lab for studying the forces that shape our universe. Each glowing strand, every shining star, and each dark patch of dust tells a story that has been unfolding for billions of years. In the scene, you can see a complex cosmic environment with blue and pink wisps floating against a darker background. Small stars sparkle like distant jewels, their light breaking through thick clouds where they were born. Larger stars display a bright 8-pointed pattern, a result of starlight interacting with the telescope's advanced instruments. This display of twinkling stars is the result of an ongoing cosmic cycle known as star formation. In these stellar nurseries, newly formed stars emit strong radiation, which heats the surrounding gas and dust, triggering the formation of new stars in a continuous loop of creation and luminosity. Recent observations across a wide range of infrared wavelengths have focused on specific bands that are sensitive to emissions from substances such as methane and polycyclic aromatic hydrocarbons, or PAHs. The detection of PAH emissions suggests the presence of heated gas and dust, whereas methane signifies cooler, low-mass celestial objects. Through this research, astronomers have identified a population of brown dwarfs, often termed failed stars, which possess masses around 10 times that of Jupiter. Brown dwarfs exist in a distinct category within the universe, bridging the gap between stars and planets. Their masses range from 10 to 90 times that of Jupiter, yet they do not have sufficient mass to ignite the nuclear fusion processes typical of true stars. Insights gained from the James Webb Space Telescope enhance our understanding of various stages of stellar evolution, as well as the dynamics of planet-forming disks surrounding massive stars, contributing to our comprehension of the complex processes that govern the cosmos.